Good afternoon. Welcome to today's Fundamentals of Measurement and Verification Training Sneak Peek webinar. My name is Chris Balbach, and I'll be delivering the webinar for you today. We have about an hour of time this afternoon to go through again some of the key fundamentals of measurement and verification in accordance with IPMVP. Due to the large number of folks who are attending the webinar today, I'm going to have to mute everybody on the line. So I'd like to ask that if you do have questions during the webinar, if you could please enter them using the question pane. The questions pane can be found at the bottom right of your GoToMeeting pane. And again, if you just type in a question, I will see them. And towards the end of the webinar, if we happen to have extra time, I will answer a number of those questions. If I don't have time and I get some key questions, I will answer those questions offline and send you a link so that you can view them. This presentation will be recorded and will be available on the PSD website at www.psdconsulting.com. So we're going to spend the next hour, 55 minutes or so, talking about measurement and verification and the fundamentals of M&V. And particularly, we're going to talk about the CMVP. The CMVP stands for Certified Measurement and Verification Program. It is a certification program offered by AEE, the Association of Energy Engineers, in alliance with EVO, the Efficiency Evaluation Organization. And on this slide, I have the 4 bullets which really represent the purpose of the CMVP training program. Number 1, to raise the professional standards of those engaged in M&V. 2, to improve the practice of M&V by encouraging professionals to partake in continuing education. Number 3, to identify the people or persons with acceptable knowledge of the principles, the core principles and practices of M&V, through completing and certification and fulfilling prescribed standards of performance and conduct. And again, number 4, to award special recognition to those professionals who have demonstrated a high level of competence and ethical fitness in measurement and verification. What it really boils down to, the purpose of the CMVP program is to build capacity of a trained and recognizable force of M&V professionals. We really, right now, in this country, have a lack of folks who can provide M&V services at a level that's really on par with what's expected by the CMVP certification. So, again, the purpose of this program is to increase the capacity of people who can deliver those services, professional services relating to measurement and verification activities. Why? Why would somebody even consider purchasing M&V services, whether that be an owner or a property manager? Why? Well, the rationale behind M&V is essentially proof of performance. As we see investment capital flowing into the energy efficiency market, we're now seeing a secondary effect, which is what happened? How effective was the use of that capital? And on the slide again, we see here that many people perform energy audits, and the results of those audits are reports that predict some level of the potential of an ECM or a capital investment related to energy efficiency for that investment to perform. The audits provide a potential of performance. Perhaps a number of measures will be chosen and get installed, and there's a whole other field here of commissioning, which again provides proof of installed potential to perform. So we turned the building over, a number of ECMs were installed, tested, and functionally operated at all operating modes and so forth. The third piece here is measurement and verification, which is designed to provide a reliable documentation of measured proof of performance. So this is long-term. This is beyond commissioning. This is into the life of the building, the life of the measure. And just as our friend Ronald Reagan was known for saying, trust but verify. Yes, we trust that ECMs are being installed correctly and being commissioned, but the M&V function, measurement and verification activities, are the verification that the ongoing performance of an energy efficiency investment is occurring. So that's the real rationale behind choosing to invest in M&V. You'll hear a lot when we start talking about M&V. There are two key documents, two fundamental documents. We cover these again in our CMVP courses. The first one is IPMVP Volume 1, the 2012 edition. IPMVP Volume 1 is titled Concepts and Options for Determining Energy and Water Savings. It is the Bible. It is literally the Bible for developing M&V plans. And you'll hear people say, again, my plan is adherent to IPMVP. Well, this is the document that describes what that means. A second document titled ASHRAE Guideline 14, which was published in 2002, is titled The Measurement of Energy and Demand Savings. And we refer back to this again during our CMVP courses. The Guideline 14 document is much more robust in terms of the technical details that surround measurement and verification activities. So Guideline 14 covers such things as uncertainty calculations, measurement uncertainty, sampling uncertainty, much more mathematical rigor covered in Guideline 14 as opposed to IPMVP Volume 1. Now there are some appendices in IPMVP Volume 1 that cover details, again, like propagation of uncertainty, but there's much more detail in the Guideline 14 document. The IPMVP Volume 1 book can be downloaded for free from the EVO website just by simply registering. The ASHRAE Guideline 14 text is a purchase document from the ASHRAE bookstore. Both of these documents are key fundamental blocks of M&V reference documents, probably the two that are used most commonly to develop an IPMVP adherent measurement and verification plan. So when we start talking about M&V, let's back up a little bit, back up to, say, the 30,000-foot level and say, what are we really talking about here? And what I have on this slide is a representation, a graphical representation of IPMVP Equation 1. So this is in the IPMVP Volume 1 document. And you'll see here just a chart. We've got time on the x-axis, and we've got some energy on the y-axis. The chart is broken up into three periods. On the left, you see a baseline period. That's pre-retrofit. That's before any investment was made relating to any energy conservation measure that we're trying to measure the performance of. The second period to the right is an installation period. And then on the far right, you see what is called here on the slide a reporting period. It's often called a post-retrofit period. What's important on this slide is that you'll see an area shaded. And the area shaded represents savings during the reporting period or savings during the post-retrofit period. And the savings is really reflective of the area between the red trend, which is essentially the baseline period forecasted forward, and the reporting period, which is measured data. So this is a graphical representation of IPMVP Equation 1, where savings equals the baseline, adjusted baseline, minus the reporting period. And there's one little step in there that we'll see if you look toward the top, baseline plus adjustments. And there, again, we covered this in the CMVP course. What do we mean by adjustments? It could be routine adjustments or non-routine adjustments. The important part for this chart is it's not simply pre-bills, pre-energy use minus post-energy use. Savings is not, that's not IPMVP Equation 1. It's a bit more complicated than that. One of the key things that we talk about in our CMVP courses are the principles of IPMVP adherent plans. And you'll see again in the M&V activities, of course, they're not cheap. This isn't additional cost that someone has to bear. So we are constantly, as M&V practitioners, balancing the value of the M&V versus the cost to administer and deliver it. And in that balance, we are weighing these 6 terms: the accuracy, the completeness, the conservativeness, the consistency, the relevance, and the transparency of our M&V activities. I highlighted on this slide transparency because I think it really trumps all others. Really, this is a key component of measurement and verification, as we are exposing our assumptions behind all of this. And I again believe that is just key to the whole process working. What's important to note here is that IPMVP nor Guideline 14, they're not standard documents. They're not standards. They're guidelines, as Guideline 14 is, and the protocols, as IPMVP is. So because they're not a standard, there's a lot of interpretation that needs to be applied. The decisions will need to be made when we're developing an M&V plan and whether we're implementing that M&V plan. And again, the core principles here, when we have to make a decision, we look back to these principles and they guide us in the decision that we make. Something I'm seeing in the marketplace recently, say the last year, is an increased interest in M&V focused on improved risk management, improved management of risk associated with investment, again, in energy efficiency as a resource, as an actual investment. A lot of this I've seen coming from the Investor Confidence Project, which is a project funded by the Environmental Defense Fund. You can go to their website, eeperformance.org, and read much more about this. But I just threw on this slide again. You'll see both on the baseline core requirements, the column to the left, the Investor Confidence Project references ASHRAE Guideline 14 as a baseline core requirement. It also, in the measurement and verification task on the far right, the Investor Confidence Project references again IPMVP option C and ASHRAE Guideline 14, and there again toward the bottom, credentials shall be either an AEE, CMVP, or 5+ years of experience. What I mean by this is we're starting to see the market demand the credentialing of those who are performing M&V, and this is just one example. You'll see this example is for the ICP large commercial track. If you read more about the Investor Confidence Project, you'll see that there's a small commercial track, there's a multifamily track. All of these are, to me, represent the emerging standards that are being developed to support investment in energy efficiency. And again, we're starting to see the credentials themselves be a part of this standard. So it's a very exciting time to be participating in the M&V arena. You'll see here I took from the core principles of IPMV of the Investor Confidence Project just to show more about what I mean by this. For example, ICP is stated goals: reduce transaction costs and source high-quality deals. So again, move investment in energy efficiency. Provide bankable underwriting with actuarial standards. That means bring third-party financing into this mix. Unlock reliable and measurable demand-side resources. That means get away from supply-side renewable, whether it's solar, PV, wind, and so forth, and start looking at energy efficiency as a resource. And finally, increase transparency and provide a roadmap for private capital to enter this market. To be frank with you, M&V is the underpinning for all four of these. Quality M&V activities underpin all four of these ICP goals. Another piece on this, which has to do with measurement and verification, is talking about the uncertainty of savings. I call it the second dimension. If you look at how most of us, many of us, including myself, we look back a few years ago, it was not uncommon to hear me state some sort of savings just as a net number. We believe this investment will save this many kilowatt hours over this period of time. Purchasing a new chiller would save you 1.5 million kWh and reduce your demand by 600 kW over a typical cooling season. That again is a prediction coming out of an audit. What happens when you actually install the measure? Well, like anything, like any actual real-world endeavor, there's always uncertainty. All measured data will have elements of uncertainty associated with it. And frankly, as we begin to use the principles of M&V to expose this uncertainty, we add this second very important dimension to our, not our predictions of, say, very low level of risk. It has a, therefore, since it has a low level of risk, we might just simply accept it. How might we understand the level of risk with lighting? Well, we might look at several lighting projects that have had measurement and verification activities implemented as a part of the installation of the lighting retrofit. We might see that the savings that were predicted did manifest, and also the savings uncertainty that was predicted was also measured. Another opposite scenario here might again be something as complex as a chiller retrofit, which has much more risk associated with the performance of that investment. There's just many more variables that are at play in something like the operation of a large central chiller plant. And honestly, only by measuring the performance of that chiller retrofit can we begin to understand the actual risk of such an investment. And then once we understand that risk, we can decide whether we want to transfer it by transferring ownership or operation of that chiller to some other entity, whether we want to avoid it, simply use in the future operating with the equipment we have, or accept it, or reduce it by, again, implementing procedures, whether that be better quality control and operating procedures to reduce the risk that we're exposed to relative to the performance of an investment related to energy efficiency. So this is a really exciting piece of M&V. In our classes, we begin to talk about how to quantify this risk. How do we begin to talk about risk when we're talking to owners and managers who are in charge of deciding what energy efficiency measures to invest in? In IPMVP and Guideline 14, we talk about 3 sources of uncertainty, 3 key sources of error, and there are many more. These are the 3 key, again, that we deal with as part of IPMVP. One is a measurement error, the second is sampling error, and the third is the error in our baseline regression models. And I've drawn up on this slide, again, some examples of, we cover this in our CMVP courses. How do we begin to talk about these sources of error with respect to their actual mathematical results? Like you'll see in the center, we have Excel model. It might be a linear regression, a multiple change point model regression. And we're starting to talk about the standard error of that regression. That would be an example of the error in our baseline model. I drew the tape measure up just as a simple example, again, of you cannot measure to a perfect measurement. There's always uncertainty related to a measurement, whether you're measuring electric use through a device, whether you're measuring flow through a pipe, steam flow, condensate flow, whatever it might be. And then at the bottom, you see the equation here. This is in IPMVP Volume 1, Appendix B, of how this error propagates. So the error in the savings propagates through depending on the uncertainty of the measurements of the sampling and of the baseline models used to generate that savings. So a core principle here that we're beginning to expose that second dimension, what are the errors associated with savings that we're measuring as a result of our energy efficiency investment. Key principles of IPMVP and Guideline 14. In our CMVP courses that we teach, we also, in general, we only use public domain tools when we're teaching these principles. Here's an example. The slide covers 4 possible tools that we use depending on what type of M&V is being implemented. ECAM, which is Energy Charting and Metrics tool, it's a free add-in that runs inside Microsoft Excel. You'll see a screenshot of that sort of to the bottom right of this slide. The Universal Translator, which again is a free tool. It's an executable application really designed to work well with interval meter data and provide estimates of uncertainty between 2 sets of data. Red Screen Plus, which you'll see a screenshot of at the bottom left. Again, this is more of a monitoring and targeting or a option C related tool, but very good for developing baseline regression equations and forecasting and savings between 2 sets of data. And finally, at the top right, you see Open Studio, which is it's an interface into Energy Plus, really more applicable to an IPMVP option D scenario for M&V, where we're creating some sort of model to represent our baseline and then savings over that, savings relative to that modeled baseline. The important thing here is that all of these tools are available in the public domain. They're free for users to download, use, and in many cases build upon. And when we cover these sorts of principles in our M&V classes, we demonstrate these tools and show our users how they can be used as opposed to building your own tool. And really, what we really don't want to see the developing M&V community do is that each user develops his or her own customized Excel spreadsheet, so on and so forth, to accomplish these M&V activities. We would much rather support these emerging public domain tools as standards for quantifying savings and the uncertainty related to those savings. So key components that we talk about in detail in our M&V courses, free tools that are accessible by all. Here's an example I just covered, and it's kind of a complicated slide, so let's go through it slowly. This is really an example of the type of stuff that we cover in our M&V courses. This would be an option C M&V plan that was executed, and this would be an example of savings reports that are included both in our M&V plan and in our M&V savings reports themselves. So this example you'll see on the left is an avoided energy savings calculation which does not include a non-routine adjustment. Now, lots of words there. We can cover that again in more detail if you read IPMVP Volume 1. But suffice it to say, you'll see the chart. Both the charts look very similar to the chart we saw 5 or 6 slides ago, which was, again, IPMVP Equation 1. In each of these charts, you see on the left the pre-retrofit or the baseline energy period. That's the red dots, the red dotted line. The red line without the dots is the model baseline, so that again represents some sort of mathematical relationship that has been created to represent the baseline period. As we go to the right, you see a little bit of a gap in data that represents the construction period or the implementation period for the project itself. And then we see data filling in further to the right, 2 sets of data. The blue data is actual measured data during the post-retrofit period, the blue line with the dots in it, and the purple line is a forecasted line, so it is the baseline forecasted forward. And you'll see there's these 2 charts. They look similar but different. The one on the left is a IPMVP adherent chart where there was no non-routine adjustment. And if you go down to the data at the bottom of that left chart, you'll see that again, these are using public domain and free tools. In this case, it was the eCam tool. We see that this project delivered 59,790 units, let's call it kWh, plus or minus 31,805 kWh at an 80% confidence level. So that's pretty much an uncertain level of savings, 8.2% plus or minus 4.4% at 80% confidence level. Wow, that's not very good estimate of savings. And this is the kind of stuff we're trying to expose. Again, we're trying that whole thing about transparency in the marketplace. If I were an investor, would I consider this to be a quality investment? Well, we have to relate that back to the prediction. I mean, was it predicted to save 15% or 5%? That would really be part of our decision. If you look to the chart on the right, we see a little bit of a different view of this, because there was what was called a non-routine adjustment made during month 4. And that non-routine adjustment resulted in more savings being generated. You see, again, I've highlighted in red at the bottom of this chart. Now we have 102,827 kilowatt hours, plus or minus the same level of uncertainty, 31,805 kilowatt hours at a 80% confidence level. So while these 2 savings estimates are very different, one represents an M&V plan that was executed without a non-routine adjustment. One represents one that was with a non-routine adjustment. And wow, look at the difference now, 13.4% plus or minus 4.1. So this is the kind of stuff we cover again as part of a CMVP course, where we need to make sure our CMVP practitioners understand how to generate savings estimates with both precision and confidence, and understand how to perform both routine and non-routine adjustments. At the bottom line, this is what M&V is all about. Communicating this to the owner investor, and then what do we do with it? So we've certainly exposed some level of risk here. Did it meet our expectations? Did it not? What has to happen here? So this is, although it's a complex slide, there's a lot on it. I think it says a lot about what we can learn and communicate. I think that owners that we work with can understand the graphical scenes here, the graphical charts, much better than the numbers, but the numbers add that second dimension that we talked about. And as we begin to work at exposing that second dimension to our owners, they begin to understand where they want to direct more of their capital towards energy efficiency investment. So as part of this training, I would like to make sure that I point out that we do have in New York State some CMVP courses that are coming up. We have one on July 14th in New York City, a Fundamentals of Measurement and Verification class that we are having that has, on the 3rd day, the CMVP exam will be administered. Also on November 12th, we have the same location in New York City, the same course, 2.5-day course with the CMVP exam administered on the 3rd day. And if you live or work in New York State, you may be you may be eligible for a 50% training, a 50% subsidy for this training through NYSERTA Training Pond. And if you go to our website again, you can check that out and read to see about the eligibility details at psdconsulting.com. Now, by no means this is not the only place that CMVP courses are offered. They're offered internationally. There's much more activity happening internationally right now than even in our own backyard. But both AEE and EVO are offering CMVP courses domestically, outside of New York State, and internationally. You can go to the AEE website and see upcoming CMVP courses that are offered. There's one coming up in September in Washington, D.C., and also there are, again, many in Canada, Mexico, and also overseas. So please check those locations out to see where other M&V courses are being offered. So I'll close out our webinar here by just thanking you for participating today. I hope I gave you a background, some background information for why you might consider attending a CMVP course or Fundamentals of Measurement and Verification course, why you might consider taking the exam and becoming a certified M&V practitioner, what you would learn from it. Just frankly, to be honest with you, having that ability to start to speak the language to the investors, which is not just the savings estimate that comes from some audit, but actually the measured and verified savings from the installation of a real investment, and having the ability to communicate to those investors to help them understand where they should consider migrating their investment in order to minimize their exposure to risk. That's a very valuable skill. And certainly we want to help folks gain that skill, learn how to execute M&V plans, both develop the plans and execute the plans themselves as part of the training. So I'll close here by thanking you for participating in today's webinar. A few websites that I did throw up here for our psdconsulting.com/calendar/training/New York State trainings, where you can see not just the fundamentals of measurement verification, but other courses that are funded through the same NYSERTA Training Pond. And again, I would encourage you to check out the AEE website for non-New York State trainings and the EVO website for non-North America M&V trainings. I hope you found today's webinar informative, and I look forward to working with you in the near future. Let me go now to see if we have any questions that I can address, and see what came in through the crowd while I was talking. So, okay, well, it looks like the questions that were submitted, they don't really look like any ones that no. So I think I'm going to just go ahead and close the webinar for today. And again, I thank you for attending, and hope I see you soon in one of our classes or one of our online webinars. Thanks again. Have a great day. Bye-bye.